Hello, my name is Steve Bowler, and in this lab we're going to be taking a look at Enhanced Interior Gateway Routing Protocol, EIGRP. Specifically within EIGRP, we're going to take a closer look at filtering routes using distribute lists. Specifically in this example, we're going to be using prefix lists within our distribute list command to filter routes in EIGRP. If you've viewed our RIP Lab 6, RIP Lab 6 is where, RIP version 2, Lab 6 is where we were doing filtering with distribute lists as well. However, in that example we were using access control lists to do that. In this lab though, I want to show you an alternative to ACLs, which is prefix lists, and I want to show you guys a couple of features within the distribute lists feature that we can use the prefix lists for. So what we'll do here is we'll use EIGRP. We're going to be using EIGRP in this lab to show you how you can filter routes in EIGRP using the distribute lists by referencing prefix lists that we create within our router. So what we have here is a simple EIGRP topology. We have router 1, 2, and 3. They're all on the 172.16.123.0/24 network. So they're all connected to the switch. They're all in the same VLAN. And as you can see on router 1 we have loopback 10, which is the 10 network. Router 2 has loopback 20, which is the 20 network, and router 3 has loopback 30, which is the 30 network. Also what I'll do here for our labs, for one of our examples with prefix lists filtering, we'll just create a loopback of, loopback 9 on both router 2 and 3. And we are going to show you how you can filter using a prefix list, how you can filter within EIGRP, specifically here in this example, how you can filter, a network specifically from one of your peer, one of the routers that you're peering with your routing protocol. Specifically in this example, it's going to be from a neighbor. So we're going to be with our adjacency maybe to router 3 is what we will show you how to deny this this network from coming in. So okay, so let's go ahead and I'm going to go ahead and get the routers configured. So just give me 1 second, and then I'm going to pause the video now and I'll be back in 1 second. Okay, so I'm back. I got the routers up and running. So let's go ahead into the routers here. Router 1, as you can see, all these routers are using its fast Ethernet 0 interfaces to connect to the switch. So it's going to make configuration here pretty simple. So we'll go under interface fast Ethernet 00 on router 1. We'll do the IP address 172.16.123.1/24. We'll go ahead and do a no shut here. And then we'll go ahead and bring up interface loopback 10. We'll do an IP address of 10.0.0.1/24. We'll go ahead and enable EIGRP process 1. Then we'll go ahead and do a no auto summary to disable summarization on classful network boundaries. That's why we do no auto summarization. And next here, what we're going to do is configure our network command. So we'll do 172.16.123.1 So this is a host mask. This is going to just run the EIGRP process on the interface with this IP address. Also, we'll just do the 10 network for simplicity. Let's go to router 2. Interface fast Ethernet 00. We'll give interface fast Ethernet 00 the IP address of 172.16.123.2 with /24 subnet mask. Go ahead and do a no shut. Then we'll go under, let's see, on router 2 we have loopback 20. Give it the IP address of 20.0.0.1 /24. Then we'll go under EIGRP, and as you can see here, it's going to be autonomous system is going to be 1. We're going to do no auto summary, and then we'll put our network commands here. So 172.16.123.2 with the host mask. So we should see the neighbor relationship come up before I could even finish the sentence. There it is with router 1. Then we'll do our network for 20.0.0.0, advertise our loopback 20 interface into EIGRP. Then we'll go into router 3, and we'll go ahead and get router 3 configured here. Interface fast Ethernet 00 again, 172.16.123.3 /24. We'll go ahead and do a no shut. Then we'll go under interface loopback 30. We'll do the IP address of 30.0.0.1 /24. Then last we will go under EIGRP autonomous system number 1. Do a no auto summary. We'll advertise our directly connected interface fast Ethernet 00 into EIGRP with the 172.16.123.3 command here with the host mask. And then we'll go ahead and do the 30 network here on EIGRP as well. So now what we should see, if we go to router 1, we should see, well, if we go to any router, since we're on an Ethernet segment, we're all in the same segment here. If I do a show IP route, or show IP EIGRP neighbors, you can see that we have 2 neighbor adjacencies on router 1. Let's go into EIGRP here and make this more simple to understand here. We'll give our routers, let's see, the router ID of, usually what you want to do is give it a interface. Let's just give it the router ID of 10.0.0.1. We'll give it the router ID of our loopback 10 interface. Router 3 will go under here, router EIGRP 1. We'll give it the EIGRP router ID of 30.0.0.1. And router 2, we'll go ahead and give the EIGRP router ID of 20.0.0.1. So now what we've done is we have effectively changed all of our router IDs on our routers 1, 2, and 3 to represent our loopback interfaces here. So if I do a show IP EIGRP neighbor on router 1, let's do a clear. Okay, what I'm trying to do is find out the router ID here If I do a show run pipe to begin EIGRP, I know I'm going to be able to find it that way. Let's see if I can find it here. Let's see. 10.0.0.1. So let's go to router 2. If I do a show IP route on router 2, you can see on router 2 that I am now learning of the loopback 10 interface on router 1, and we also see the loopback 30 interface on router 3. And if I try to ping it from end to end here from router 2, from spoke to spoke, you can see that I have connectivity from loopback 20 interface to loopback 30 interface. So what we also want to do here is, what I want to show you is how to filter. In this lab, we're going to look at filtering using the distribute list command under the EIGRP routing process, and we're going to tie in a prefix list with the distribute list command. So whereas before, I think it's in my lab RIP version 2 lab 6 where we used the distribute list command and we tied in an ACL, what we're going to do, what I'm going to show you filtering with EIGRP here, I'm going to show you how to do that using prefix lists. So what we will do in this example, since all the routers have two neighbor adjacencies, so it's pretty much a full mesh. Router 1 is adjacent to 2 and 3, router 3 is adjacent to 2 and 1, and router 2 is adjacent to 1 and 3. Now in this example, what we will do is we are going to filter, let's go ahead in this example and we will filter inbound. In router 3, we're going to filter the 20 network from coming into router 3's routing table using prefix lists tied in with the distribute list. So on router 3, what we're going to do here is we're going to create a simple prefix list here. So we'll just do IP prefix list, and then the word here we'll name it in from R2, and then we'll follow it up with a permit statement, and then here we will tie in the network. So we're going to allow the 20 network in. Again here, we're going to put in the network, which is a /24 subnet mask. And we'll go ahead and we're going to just allow, we're going to permit the 20, and that is it. So let's do this. Let's show you how this prefix list is going to work. We will go to router 2. We'll create, let's see here, a more specific loopback interface. So we'll do interface loopback 21. We'll do IP address of 20.0.0.133, and we'll give it the IP address of 255.255.255.128. Oops. Actually, you know what? Okay, we'll do this. Since we already have this /24 on loopback 20 for the 20 network, 20.0.0.0, let's do this. We will go ahead and get rid of loopback 21. And we'll do this. We'll create a prefix list on router 3. Instead of it being a /24, we'll make it a /23. And I'm going to show you how this is going to work here. Now, prefix list, like an ACL, it has an implicit deny any on the end, unless you specify differently. So, with this being said, if we were to go ahead in this example now and go under our EIGRP Autonomous System 1, and we do a distribute list command, distribute list, and then put in the command prefix here. This is to filter prefixes, and then we put in our name of our prefix list, which is in from R2. If I go ahead and paste that and do in, again we're filtering inbound from R2, and then of course our interface here faster than 00. So once I do this command, if I do a show IP route, alright, so there we have the dual neighbor change, configuration change. If I go ahead and do a show IP route now, as you can see, I do not see any routes in the routing table that are learned via EIGRP. So I have effectively broken our network. So I'm not receiving a route from router 1, I'm not receiving any routes from router 2, even though I have the /23, right? And the /23 in our prefix list is going to be matching the 20.0.0.0 network, and so it'll be this, in the third octet it's going to be 0 and 1, right, with the /23 logic. However, it has to be exactly a /23 in order to match. So if I do a show IP route now on router 3, you can see that I'm still not learning any routes via EIGRP. So if I go back into if I do a show IP prefix list here on router 3, you can see I have one sequence number 5 with a permit statement for the 20 network /23. And of course this is not being allowed in. Now let's go ahead and do this. If I go back to the prefix list, and do a sequence 5, and now if I do a permit for a 20.0.0.0 /23, and if I do the command if I go ahead and change this from a 23 to a 24 so it has to match exactly a /24 network. Let's go ahead and change that. First we'll go ahead and delete it, then we'll go ahead and change it. So now we should see an EIGRP message here again in our log. We'll give it a second. If I do there we go. So now if I do a show IP route, now we can see the specific /24 that we're matching now in our show IP in our prefix list here. So again, I just wanted to show you some prefix list logic that happens if we put in a /23. What we should see with the prefix list is we should see the network match exactly as a /23. You know, if we're not using less than or greater than in there with our prefix list logic, it has to be an exact match. So as you can see, when we put that /23 in there, it rejected the /24 because that's not what it was looking for. It was looking for a /23, which it was not receiving. So now that we changed the prefix list to a 20.0.0.0/24, now you can see we're seeing the route now from router 2. Okay, so now if I go ahead and try to ping that, 10.0.0.1, as you can see I have reachability. However, what you can see is we're still not seeing the loopback 10 network from router 1. And that is because when we put this distribute list on, we had to, if you remember here, if we go back to our configuration, this distribute list is matching this prefix list in from R2, and that prefix list is coming inbound on Fast Ethernet 00. So from R3's perspective, it's also anything that's not in this prefix list in from R2 is going to be denied. Like I said earlier, with the implicit deny all at the end of the prefix list, unless if otherwise permitted within the prefix list. So as you can see here, the only match we have on R3 is for the 20.0.0.0 network /24. So again, that is a simple configuration of a prefix list inbound. I'm sorry, that is a simple configuration of a distribute list inbound tied to a prefix list instead of an ACL. Now let's go to R1 and take a look at its routing table. As you can see, it's learning of the 20 network and the 30 network. So it's still receiving routes from router 2 and router 3 because there's no filtering going on router 1. So let's do this. Let's go ahead and configure. I'm going to show you one more thing with prefix lists that we can do with distribute lists here. And then we'll go ahead and wrap this up. And in this example, what we're going to do is we're going to advertise on router 2 and router 3, we're going to advertise the 9.9.9, I'm sorry, the 9.9.9.0 network /24 on both routers. And what we're going to do here is we're going to be filtering using the distribute list. We're going to be filtering the route from a specific source. In this case, we'll filter the route from router 3 from being put into router 1's routing table. Or actually, let's do this. Let's go into router 2. Let's go ahead and do this. So you guys can see this example. We'll go ahead and do the 9 network, 9.9.9.1 /24. We'll go under EIGRP 1, do the network command for the 9.0.0.0, and router 2, I'm sorry, router 3 will do the same thing, interface to loopback 9. IP address is going to be 9.9.9.1 /24. Now we'll go under router EIGRP1, we'll do the network 9.0.0.0, and we should be good. So now router 3 and router 2 should both be advertising the 9 network into its EIGRP process here. So router 1, if I do a show IP route, what we can see here is that we are learning the 9 network from 2 different gateways. We have router 3 and router 2 as our gateways here. They're both advertising it. If I do a trace, let's see which one it goes to. I'm going to go ahead and pause it real fast and let this trace run. Okay, so what we're seeing here is that the trace is seeing both router 3 and router 2 in the routing table, and it's trying to route to both of them. So what we can do here with the distribute list filtering with the prefix list is that we can filter routes from a specific source. And we're going to do this by creating 2 prefix lists. We're going to first identify the networks in which we want to filter, and then we're going to then create a prefix list in which we identify the source of the network in which we want to filter from. So in this case, let's say router 3 is not supposed to be sending us the 9 network. So what we're going to do is we're going to block, from router 1's perspective, we're going to be blocking router 3 from sending us the 9 network. Now, as you can see here, we only have one link in on router 1. So if we were to try to apply the logic of just applying a prefix list inbound, or an ACL inbound, to deny the 9 network, it's going to deny the 9 network from both router 3 and router 2, and it's not going to have a path to the 9 network at all. However, what we can do here, and that's why I set this up, as only having one, each router only having one link and being shared over the switch in a broadcast environment, to show you how you can filter based on, if 2 routers are sending you the same network, you can filter based on the source, which neighbor you want to actually filter from. Because again, like I said, if you were just to apply a distribute list, tie it in with an ACL, and try to block the 9 network, well, you're going to block it both from router 3 and router 2. But what I'm going to show you here is that you can block it specifically from a source, one of your neighbors. And we're going to do that to router 3. So we're going to deny it from router 3, and that way it's going to allow router 2 to still be advertised the 9 network. Okay, so let's go to router 1. We'll create 2 prefix lists here. First one is going to be called network. So IP prefix list network. And in this prefix list, what we're going to do is permit the 9.9.9.0/24 network. Again, this is the network coming from router 2. So we're permitting the 9 network in. And then what we're going to do is create a prefix list called source router, and then under here what we're going to do, I guess I should show you this first. If I do show IP EIGRP neighbor, we can tie this in with our neighbor address here. So what we'll do is IP prefix list we could even just call it source neighbor is going to be 172.16.123.2. I'm sorry, I have to do the permit statement here first. 172.16.123.2. I'm sorry, slash 0. I'm sorry, 172.16.123.2/32. So we're going to match as the host mask there, /32. We'll go ahead and hit enter. So now again on router 1, let's just look at the routing table one last time. If I do a show IP route, you can see we have all these EIGRP learned routes. We're learning the 30 network, the 20 network, and we're learning the 9 network from 2 different sources. We're learning it from router 2, and we're also learning it from router 3. So let's go ahead and go under EIGRP Autonomous System 1, and we'll do our distribute list command. And now what we're going to see here is we're going to use the prefix command again, distribute list prefix, and then we're going to tie that in with the name of the prefix list here, which is network. And then what we're going to see here that we haven't used before is the gateway keyword, and this is going to allow us to filter incoming updates based on gateway. In this case is going to be our neighbor address, which we showed you is router 2. So we'll do IP prefix network, then we'll do the gateway command, and then here we'll put in the prefix list in which we specified router 2 as our neighbor, our source neighbor. So the name of the prefix list is source neighbor. And then again, this is going to be inbound. So we're going to allow these updates inbound from router 2 to router 1. So now if I do a show IP route on router 1, we'll wait for EIGRP. There we go. Just converged. Had to resync. So if I do a show IP route now, as you can see, I have effectively filtered router 3 from sending me the 9 network. So now as you can see here, we're only seeing the route from router 2. We no longer have both of the 9 networks coming in. A key thing though that we have to remember here when doing this type of filtering based on the source neighbor, in this case router 2, from router 1's perspective, now you can see our routing table for EIGRP learned routes is significantly less. So we're not seeing the 20 network, and we're not seeing the network from router 3, which is the 30 network. So in filtering just the the 9 network from, to be allowed in from router 2, we've also filtered other routes as well. To get some of those routes back, if we go to router 1 here, we do a show IP prefix list here. If we go into the IP prefix list network and do a sequence number 10, then we do a permit 20.0.0.0/24. What we should see here in a second, when the two neighbor adjacencies reconverge, what we should see here now is show IP route on router 1. We do now see the 20 network from router 2 as well, and we can ping. And we can also ping the 9 network from also being advertised to us now on router 1. So again, this is just another way to look at filtering based on a specific source neighbor that you want to filter and allow in. So in this case, we had router 2 and 3 both sending us the 9 network, and we wanted to allow inbound into router 1, we wanted to allow in the 9 network from router 2. So we did this by, on router 1, we created 2 prefix lists. Again, first prefix list was the network prefix list, which allowed the specific network in which we wanted to permit inbound. And then we also created the second prefix list, in which we matched our EIGRP neighbor, in which we wanted to allow the 9 network inbound, which was 172.16.123.2, which was router 2. And we also, last but not least, we went under the EIGRP Autonomous System 1. We went under EIGRP and did the command distribute list prefix, in which we matched the prefix list name network. And then we specified the gateway command, or the gateway option within the distribute list, which points us toward the gateway in which we want to allow this network inbound on, which was the prefix list we created, which was the source neighbor prefix list, in which we matched router 2 with the host mask here /32. And then we did this, of course, inbound from router 1's perspective. Okay, so let's go ahead and I'm going to show you one more key point here with this example, and it's going to deal with our source neighbor. If we go to this prefix list called network, and we go in here and we add, as you can see here, if we do a show IP route on router 1, we don't see the 30 network, which is advertised to us from router 3. If we go into router 1, okay, and we go do a IP prefix list network and add a sequence number here 15, and then try to add in the 30 network, let's see what happens. Whoops, forgot the permit statement. So permit 30.0.0.0/24. We'll go ahead and hit enter there, and we'll go ahead and let EIGRP reconverge. If I do a show IP route now on router 1, what you can see here is if I do a show IP prefix list, although I have allowed now in the 30 network, in our prefix list network, what you can see is that it is not being allowed in the routing table because of the principle of this specific type of distribute list option, where we are matching networks from a specific gateway. In this particular instance, our gateway is router 2, so it's only going to apply from routes being advertised from router 2 to us. Even though router 3 is advertising the 30 network to us, router 1 is denying everything from router 3 at this point. It's only allowing in routes from router 2 that is specified under the network prefix list in which it originates. And you can see here from router 2's perspective, router 2, even though it's seeing the network to the the 30 network, it's not originating this network. So let's go ahead and see if we can see any of this action being taken here on router 1. If we do a debug IP EIGRP 1, okay, now from router 1's perspective, when we did the debug IP EIGRP, what we could see is we did see a couple of options here showing, specific routes, EIGRP routes being installed. Route installed for the 20 network and route installed for the 9 network. However, it looks like here we did see the 30 network coming in. However, it's not installing this network into the database at all. So again, this route is not originating from router 2, so it is not going to be allowed into the routing table on router 1. Again, if we go to router 2 here, let's not create another loopback. I think you guys understand the point that what I'm trying to get to here is that with this specific type of distribute list, the prefix list here, in which we are matching router 2 is originating the 20 network and the 9 network, and it's sending it to router 1. Router 1 has a prefix list on here for the network, which is allowing the 9 network and the 20 network and the 30 network. Now from router 1's point of view here, we also have, if we do a show run pipe to begin EIGRP, we have a distribute list here tied in with EIGRP that's matching the prefix list network, which are these three networks. And it has the option, the gateway option, from the source neighbor of router 2. Now what we tried to do is we tried to trick router 1 into allowing the 30 network in. But what we found out here is that even though router 2 is learning the 30 network in its routing table, it is not able to pass these routes in to router 1. Okay, so again here we looked at filtering EIGRP using distribute lists. Specifically with distribute lists, we looked at a couple examples of using prefix lists and how prefix lists work with distribute lists. So I hope you guys have enjoyed this video, and I'd like to thank you for watching.